Alright, next quick topic we're going to look at is allocation of frames. So, as the name suggests, your RAM is divided into frames. You're getting some data from the virtual memory corresponding to one or more processes, and you're going to put it in these frames. So, there are two questions, right, about mapping the frames to the data or the processes. How many frames per process and which frames? So those are the questions this topic called allocation of frames is going to discuss. So how many frames per process? What does the question mean? First of all, my RAM has, let's say, some 100 frames or whatever. I'm going to bring in a few processes from the virtual memory and store them in these frames. Let's say I'm bringing in 5 processes. How many frames is each process going to get? So there are two different ways. Either you can do something called equal allocation, which means each process gets equal number of frames. So if I have 100 frames in my RAM and I am importing 5 processes, then each is going to get 20 frames. Or I can do what we call the proportional allocation method, meaning the number of frames a process gets is directly proportional to the process size. So if your P1 is very small, let's say it will get 5 frames, and if P10 is pretty big, it's going to get 25 frames, and so on and so forth. So I think that's pretty self-explanatory. That answers the question, how many frames per process. So there are these two options. You can choose to allocate whichever way you want, depending on your memory, your system architecture, so on and so forth. The second question in this context is which frames for a process. So what do I mean by which frames is, we'll go with the same example. There are 100 frames. Let's say the frames are numbered 1, 2, 3, 4 up to 100, right? So is there a specific mapping kind of a thing, like this process should only access frame numbers 1 to 20, this process should only access 21 to 40, and so on? Is there something like that? That is what this second question is. So this, again, you have two options. A, global replacement, meaning any process can choose any frame and replace it. What do I mean by replace? Let's quickly go back here. So let's say 701, your frames are full. Now this 2 is coming in. It sees the frames are full, so it has to kick out one of these people and occupy that place. Sorry. So yeah, 701 frames are full, 2 comes in, it has to kick out one of these and occupy that place. So in global replacement, the choice is, it is free. The entire physical memory is available. You can choose from any of these. You can choose to kick out any of these and occupy that place. Of course, how you make the choice depends on what page replacement algorithm you are using. If you are using FIFO, maybe you will choose to kick out this one. If you are using LRU, maybe you will choose to kick out this one. That is there. But the idea is, all of these are potential options from which you can choose to kick out if you go by global replacement. If you are going by local replacement, then you have a range allocated to every process. So P1 can only use frames 1 to 5. P2 can only use frames 6 to 10, and so on. So we will go to this one maybe. Wait, or this is a better example. So this entire thing is your physical memory, right? Now if I am dealing with global replacement, if I am bringing a page and I see this is full, I can take all of these as options, and then I can apply either FIFO or LRU or optimal or whatever, and I can choose from all of these which frame I want to clear. If I am doing local replacement, it means there will be sorry for the interruption. So if we are doing local replacement, there will be a specific bunch of frames. Let's say frames 1, 2, 3, 4, 5. Only those are accessible to me. Within that, I can do FIFO, I can do LRU, I can do optimal, I can do whatever, and I can choose. But even if all the others from 6 to 100 are free, I cannot use them. Only within these 5, I have to make my choice. So that is what we call the local replacement policy.